Today we are talking about the topic measurement and experimentation. So we already know that measurement is a physical quantity. So we need some instrument to measure this physical quantities. Suppose we are taking as a length and time. So we need some instruments to measure these particular measurements. So for suppose we are taking a length, we need centimeters as well as kilometers we are using for finding out the distances or length. And in the case of time, we are using seconds, minutes, hours as well as day. Okay, we are counting by the instrument of watch, all these things we are using. So in this chapter mainly we are considering all three instruments. These are vernier calipers, screw gauge and simple pendulum. So first topic is vernier calipers. This is the instrument called vernier calipers. It is used for finding out the outer diameter, inner diameter as well as the depth of small containers or beakers. So first we will discuss about the parts of vernier calipers. So this is vernier calipers. Here you will see numbers given. This is called the main scale of vernier calipers. So here two dividing parts are given. This is called jaws, and this is outer jaws, and this is inner jaws, and one tail is like a string. It is given that is used for measuring the depth of the containers or beakers. Apart from this, there is a small scale given in this, that is called a vernier scale. So there are only 10 divisions, and in a main scale there will be it is given in centimeters. So you can see this. So outer jaws are used for finding out outer diameter, and inner jaws are given for finding out the inner diameters, and this string is given for finding out the depth of the containers. So we will discuss about the function of our least count. First we will discuss about the least count of the vernier calipers. So least count means the smallest division of an instrument used for a measurement. But in the case of vernier calipers, least count is a little bit different. Once the least count is smaller, the measurement will be accurate. Once again I repeat, the least count is smaller, the measurement will be accurate for using the instruments. So we will discuss about the usage and finding out the least count. So finding out the least count is very simple. So there are some divisions given in the main scale as well as in 10 divisions are given in vernier scale. So to find out the least count, we have to take a division from main scale, and it should be divided with the total divisions from vernier scale. That means, so one divisions from main scale and total divisions from vernier scale. There are 10 divisions in a vernier scale, so the least count will be 1 divided by 10 mm. Mm means millimeter. So 1 divided by 10 millimeter, it should be 0.1 millimeters, and it should be written it should be converted to centimeters. That is equal to 0.01 centimeters. That will be the least count of this given vernier calipers. Okay, so you have to keep in mind one division from main scale, total divisions from vernier scale, and the least count will be 1 divided by 10 millimeters, and it should be converted to centimeter as well. Then we are finding out how we are finding out the diameter of object. Okay, suppose this is object, we need to find out the object diameter of the object. So we have to place this object in between the movable jaw and fixed jaw of outer jaws. Then we have to take the readings from vernier calipers as well as main scale reading. So after that we have to add this main scale as well as the vernier scale reading multiplied with the least count. So I will explain it very clearly. So before that we have to think about there are some problems when it is made. So when vernier calipers, some technical error will be there. So because of the technical error, zero error may occur. Zero error may occur. So we will discuss about zero error. So already we told that there are two jaws, inner and outer jaws, and outer jaw is movable, or inner jaw also is movable. And when two jaws are in contact, you see that main scale 0 as well as the first division of vernier scale, that will coincide. If it is not coinciding, it is considered as it will have a zero error. When two jaws are in contact, 0 mark of the vernier scale as well as 0 mark of the main scale is coinciding, then it is called free from zero error. So if it is not coinciding, it is called it's a zero error. There are two types of zero errors. One is positive zero error and another one is a negative zero error. Positive zero error and negative zero error. So we will discuss about negative and positive zero error. If the first division of the vernier calipers and main scale reading zero error, zero mark, and if it is in the right side, the zero mark of the vernier scale is right side of the zero mark of the main scale, it is called positive zero error. And if the zero mark of the vernier scale is in the left side of zero mark of the vernier main scale, it is called negative zero error. So negative zero error and positive zero error, it is important. If there is no zero error, you can continue with the calculations. It will be accurate calculation. And if there is a zero error, you have to subtract or add with the total readings which you have taken, then only you will get an accurate reading. So finding out the zero error, already I mentioned that if the zero mark of the vernier scale is ahead of the zero mark of the main scale, it is called a positive zero error. Then there are 9 more divisions given. So one division will be exactly coinciding with the main scale divisions. Okay, in this case, the third line is coinciding with the main scale reading, so that if there is a zero error, you can count which line of the vernier scale is coinciding with the main scale, so that the number is calculated, number is taken. So if the third line is coinciding with the main scale reading, so we are taking 3. So third number is taken and it should be multiplied with the least count which we have found out into 0.01. Therefore, we will get a 0.03 as a positive zero error. The sign is important in this case, positive zero error. In the case of negative zero error also, we are taking that coinciding lines. Suppose if the fourth line is coinciding with the main scale reading, so we are taking the number of 4 and multiply it with the 0.01. That means the least count, you will get a 0.04. So in that case it will be negative. So negative zero error as well as a positive zero error. So when we are calculating that one, the total reading, so main scale reading plus vernier scale reading with the least count minus positive or negative zero error with the sign. Positive or negative zero error with the sign we have to put. So because if positive cases, positive zero error is there, then we will subtract from to find out the total reading. And if negative zero error, if it is occurring, so we will be adding. So minus into minus will become as a positive term. So negative zero error will be added and positive zero error will be subtracted from our total reading. How? That's why we are finding out the readings. And again we are telling to find out the outer diameter of the object. Okay, outer diameter of the object. So minimum 3 times you have to take the reading of this object. Minimum 3 times. Then you will be thinking how it will be. So in different places. Okay. So main scale reading will be without changing, and vernier scale will be somewhat it will be changing. So let us discuss about this one. So I have fixed this one inside the outer jaws. So the main scale reading, okay, main scale reading is given that 3.2. So
Okay.
So we are discussing about the diameter, inner outer diameter of the given object. So already we fixed the object in between 2 jaws. Then we are calculating the main scale reading, okay, which is given there on in between these 2 layers. So the zero mark of the vernier scale is coinciding in one number. That will be your main scale reading. Zero mark of the vernier scale is coinciding with one number. That will be your main scale reading. In this case, this is a 3.1. So we are taking on the main scale reading as main scale reading. In short, we will write MSR, main scale reading. It is a 3.3 centimeters. So it is taken in centimeters. Now we are finding out which line of the vernier calipers is coinciding with the main scale. So one line will be exactly coinciding with the line of main scale reading, one line of main scale reading or one division of main scale reading. That number, the particular number we have to take. So in this case, number 7 is coinciding. The 7th line is coinciding with the one digit of main scale reading. So we are taking this as a vernier scale reading. Vernier scale reading equal to the 7th line is coinciding and it should be multiplied with the least count 0.01. That will be equal to centimeters. So 0.07 centimeters. So we already found out the main scale reading as well as vernier scale reading. So total reading is equal to total reading is equal to MSR plus VSR. That is equal to 3.3 plus 0.07. That is equal to 3.37 centimeters. The unit is very important. 3.37 centimeters. That will be the reading of the diameter of the given object. Again, we are taking the diameter. So just move this movable jaws. Then keep the object like this. The reading should be taken as I have shown in the board. First main scale reading should be taken. Then vernier scale reading should be taken. That the number should be multiplied with the least count. Then the total reading, main scale reading plus vernier scale reading. That will be the total reading. And before you start the experiment, make sure that your instrument is free from zero error. Okay, already I mentioned, if the two jaws are in contact, if zero mark of the main scale as well as zero mark of the vernier scale should coincide each other. If it is not coinciding, it occurs as zero error. If it is free from zero error, you can go with the total reading. If there is zero error, if there is positive zero error, then the number should be subtracted from this. Suppose 0.03 is the positive zero error, the number should be subtracted from the total reading, then you will get another reading that will be as your total, exact total reading of given object's diameter, outer diameter. So we discussed about outer diameter. Then we are going to tell about the inner diameter of the given object or a pipe. So in that case, we have to fix this object in inner jaws, and it should be fixed like this. Okay, it should be fixed like this. Tight it should be. Then the reading are same I had given on the board or I had explained. The main scale reading should be taken and vernier scale reading is taken. Then for a total reading you have to add main scale reading plus vernier scale reading, which is multiplied with the least count. And the third one is finding out the depth of the object or beaker. So we had a spring there. So you just place this one inside the object and it should touch the bottom level of the beaker and it should be like this. Bottom of the vernier scale and the spring should be touched on the bottom part of the beaker. Then the same reading should be taken as the same main scale reading as well as a vernier scale reading. So I think you have all understood about this topic. So very important that before you start the experiment, you make sure that it is free from zero error, and calculating the main scale reading and the zero mark of the vernier scale is coinciding with the division of a main scale reading. That will be your main scale reading. Then one line of the vernier scale will be coinciding with the one division of a main scale reading exactly. Then that will be taken as your vernier scale reading, and that number should be multiplied with the least count. Is it clear? I hope you all understood about using the vernier calipers. Then next one is a screw gauge. Next one is screw gauge. Same as vernier calipers, screw gauge also is used. Okay, for finding out the diameter of a thin object like wires, papers, all these things we are using the screw gauge. So in this screw gauge, uh, here we are keeping the object and fix it. This is called a ratchet. So when you tighten it, you use the ratchet to tighten the object. So after that you will get a tick sound. That sound when you hear this sound, just stop tightening. So like vernier calipers, screw gauge also there are two scales. One is main scale. So here it is clear, it is main scale, and one circular scale is present over there. So the numbers are given up to 100, 0 to 90 numbers are given. So the total divisions of a circular scale is 100. So in main scale it is given in a millimeters. Circular scale also it is given in a millimeters. So above the numbers there is a small line given that is called a baseline. Okay, that is baseline. So like vernier calipers, screw gauge also will have zero errors, positive zero error as well as negative zero error. How to find out positive zero error as well as negative zero error? When two studs, it is called studs, two studs are in a contact, see the main baseline and the circular scale. Okay. If the circular scale 0 is not coinciding with the baseline of screw gauge, it is called, it will have a zero error. If the zero mark of the circular scale is coinciding with the baseline, then it is free from zero error. If the zero mark is above the baseline, it is called a positive zero error, and if it is below the baseline, it is called a negative zero error. Then finding out the zero error exactly. So in this case, the zero mark of the circular scale is above the baseline. Above the baseline, so it is called it will have a positive zero error. So positive zero errors, it is given 93rd mark is given, so we have to subtract it from 100. So it is called a negative zero error, it's not positive zero error, it is negative zero error. If it is zero mark of the zero mark of the circular scale is below the scale, means baseline, it is called a positive zero error. Above it is called a negative zero error, and it is 94th line is coinciding with the baseline. So we have to subtract the 94 from 100. So you will get 100 minus 94, that is equal to 6. So it should be multiplied with the least count. So for finding out the least count, like vernier calipers, what we have done, one division from main scale, one division from main scale, and total divisions from vernier scale we have taken. Same case is also repeated in the case of a screw gauge also. One division from a main scale, that is equal to 1. Total divisions from a circular scale. In the circular scale there are 100 divisions given. So 100 will be taken. That is given in a millimeters. This is also given in a millimeters. So 1 divided by 100, that is equal to 0.01 millimeters. That is equal to 0.001 centimeters. So vernier screw gauge is more accurate than finding out the measurement from comparing to vernier scale, vernier calipers. So already we found out the total divisions and least count of screw gauge, and here we found